Yeah, good morning. We'll start with the lesson now. In the last class, we had completed the module 2. That is, in a module 2, we had discussed how a data link layer will be there, how we can getting start with the link capacitors. So how the link capacity will work, how encoding will be done, and then how the framing will be done, and then afterwards how the error detection and corrections will be done. Then afterwards we have discussed the reliable transmission, that is how the sliding window protocol ARP will work. So all these things we had discussed, and then afterwards we have gone with Ethernet, how Ethernet frame will be there. So that and all we have discussed how Ethernet transmission algorithm will work, one persistent. That also we had discussed, and later on we completed that particular model. Now we'll step into the next particular model. In this model we are going to discuss about internet working. Internet working, almost all like network layer we are going to discuss now. How, what are the functions of this particular network layer, and how the network layer will work. After the data link layer, the next thing is on a network layer. So how the different functions will help in a present internet scenario, how the IP protocol will work like that. We'll see all the sequences, functionalities, and how a routing will be done, how a packet will be taken into considerations, then how different networks will be taken into considerations, then what is the work of a router, what is the work of the manageable switch, the where actually the router in that video of the video what I have shown you the movie in the beginning. In that the router has actors, how this particular router will do the work, and then how the particular ports will be taken into the consideration. So all these things we are going to discuss in this particular unit. Now we'll go through that particular unit. We'll start today with an introduction. Just a minute. Yeah, right. There's a one. Yeah, internet working. Now coming to the first the outline of this particular chapter. Here we are going to discuss the switching and bridging and basic internet working, that is IP. Means only basic. Advanced concepts we will discuss in a next chapter, including both chapters third and fourth. Module 3 will be covered. Now switching and bridging, we'll see how a switching will be done between different LAN networks, and then how a bridging will be done with the different networks which will be taken, and then how the basic IP protocol is going to be works. Now, what will be there in this particular chapter? Understanding the functions of switches, bridges, and routers. As I told you, in a network layer, these devices will play a very much important role to connect from one network to the another network and to build a vast network. In that particular sense, these switches, bridges, and routers plays a very much important role. Coming to next, discussing internet protocol, means IP protocol. Presently in a TCP IP architecture, I have shown you that after the net layer, the next layer will be IP layer, and I have told you that this is a art of that particular internet today, and entire internet is depending on this particular protocol. We'll discuss on this particular protocol how it will interconnect the networks, and how a routing will be done from source to destination, how that route will be maintained in a routers. So all these things we are going to discuss in this particular chapter. Now coming to the first thing, that is switch. What is a switch actually? A mechanism that allows us to interconnect links to form a large network. So what is a switch here? A mechanism that allows us to interconnect links to form a large network. That is, one network is there, and another network is there. Taking the two networks, we are going to link the two networks and it will become one network. Like this, today, entire world we are going to take into one particular internet. Means you can imagine, just as a network engineer, you can imagine how many companies are there and how many individual internet users are there in a world, then how different networks will be there, and how the heterogeneous networks is there. You have to think like in a vast sense, not in a small sense. So how to connect these different networks under one umbrella, we are calling it as an internet today. Telling it's very easy, just we'll switch on the data in our mobiles, or just we'll connect to the router or data in our laptops, and we'll start browsing www.something.com like that. And so imagine that how this network is built and how I can easily go through with the entire world information today, and what is the background role of the network here. Once as a network engineer we will imagine that, then the greatness of that particular network mechanism and the greatness of that IP protocols will come to you in front of your eyes. Now, a mechanism that allows us to interconnect links to form a large network. That is a switch, whatever is there, it will connect the two networks together. Imagine how your switch should be capable to connect like that many systems. A multi-input, multi-output device which transfers packets from an input to one or more outputs. So this is very much important. A switch is a one which will take the multi-input, means multiple systems will keep on inputting, and multi-outputs it will give. And input will be taken from one side and output will be given to one or more ports which it is having. So that is a switch here. Coming to the next slide, adds the star topology to the links. So always the switch will do that. Means it will makes the means the star topology, a centralized point it will be there where all systems will be taken, like in our lab all systems is taken and is connected to one particular switch. But our switch is not a manageable switch which is in a lab. You must be very clear there. Sorry, it's a switch hub. Yesterday I repeated that it's just a switch hub where just it's a one line path or a bus path where all systems are connected, and the information can be transferred in particular LAN. But here the switch means you can think like this. Here the switch means it's a manageable switch. What is this manageable switch? So whether the packets, where the packets is coming from and where the packets should be done, the decision can be taken here. That way we'll call it as a manageable switch here. Now, coming to the next thing, a switch is connected to a set of links, and for each of these links runs the appropriate data link protocol to communicate with that particular node. So very clear, a switch is connected to a set of links. Whatever, how many systems is there, based on your systems, a switch will be established. 32 port or it will start from 8 port, 16 port, 32 port, 64 ports, like that it will be started. So you can take that type of a switch based on your network design, and a communication will be start with a data link protocol. Means data link protocol, whatever is there, it will start. A switch primary job is to receive incoming packets on one of its links and to transmit them to some other link. What is, it's very simple. It will take the packet from that particular link and it will transmit to the another particular link. This function is referred as switching or a forwarding. According to OSI architecture, this is the main function of the network layer. So now we are at the network layer. So what the switch we are connected there in our lab and all, it will comes almost all to hub, a LAN communication there. But here the switch means, for example, I'll tell you, lab number 1 and lab number 2, that both switches are connected together, then automatically then it will become another particular thing. So like this, if you connect two networks together with one switch, that's a manageable switch. What is the work of this particular switch here? So to which particular link or on a port the packet should be sent. The decision will be taken, means switching will be done, storing will be done, and then forwarding will be done. So coming to the next thing, how does the switch decide which output port to place each packet on? That's why I told you that this is a manageable switch. In a market, when you go for a switch, there will be two types of switches will be there. Switch hub, in regular words will call it as a hub. So switch hub will be there and manageable switch will be there. So usual words will call it as a router. Sorry, just usual words will call it as a router, but the router will do another work. The routing work will also be done there. So managing switch is a perfect word in a market which you can ask for this particular device. Now, how does the switch device which output port to be placed each packet on? It looks at the header of the packet for an identifier that it uses to make the decision. Two common approaches: datagram or connectionless approach, virtual circuit, or a connection oriented approach. A third approach is source routing, is less common. Now, as I told you that the switch will take a decision that the packet is coming from one particular port and the packet should be thrown to which output port. So how the decision should be taken? The decision will be taken in two approaches. One is a connectionless approach in our words. One is a connectionless approach, one is a connection oriented approach. What is a connectionless approach and what is a connection oriented approach? We'll discuss. Source routing I'll tell you later, but connectionless and connection oriented approaches. Very simple. Connectionless approaches is in a format of a flooding. What do you mean by a flooding here? In real time, I will tell you. So what is the connectionless approach here? The connectionless approach will be very simple, that I saw that particular person there and I want to call that particular person. Assume Ram is there at one place there. I want to call him, but he is not audible to me. Then what I will tell usually, with the person whoever is there near to me, I will tell him, please call that person. But that person also not audible to him, then he will tell other person, call that person, call that person, call that person. So finally it goes to Rama, and then he will tell, see, this person is calling, that person is calling, that person is calling, this person. Finally it's come to me, so I am calling that person. Then he will tell what? So like this, just it's a common thing. So what is a connection oriented approach? First, a connection will be decided. So first, a path will be decided. So from which particular way I should connect to that particular RAM, and once after the connection has been established, then afterwards the information I will keep on sending to him. So that is called as a connection oriented approach. We will use in our real time many times this particular approaches. Now, datagrams. What is this datagrams? First, key idea. Every packet contains enough information to enable any switch to decide how to get it to destination. As I told you in beginning of from this networks, I'm telling packet is the one which is like a cell in a human being body. Without a cells, human being is not at all there. So as a packet means it's like a living thing, a body essential which is there in a network. So that is the one. A packet contains enough information. A data will be there in that, and header will be there. That header will have enough information to take the decision to a switch that it can decide where is its destination. Yes, there. Every packet contains a complete destination address always. Now, we'll go with switching and forwarding, how it can be done. Now, observe carefully the switches, whatever it has been placed in a different networks. Switch 1, switch 2, and switch 3 is there. You observe carefully. Switch 1 is with one network, host A, C, D is connected, and switch 2 is there where E and F host network is connected. And switch 3 is there so G, B, and H is connected. Now the ports of that the switches also you can observe that means 0, 1, 2, 3 means where that the other means ports which has been connected. Sorry, next. The other one here we can see 0, 1, 2, 3. And then 0, 1, 2, 3. That are the identification of that particular ports. Now observe the diagram carefully here. First, we should know the network very clearly. Observe the diagram very clearly here. The 0 port is connected, means in switch 1, the 0 port is connected to host D, and the one is connected to other network. That you have to keep in your mind. That is where the one plays a very much important. The one is the output port here, and then the host A is connected to port 2, and host C is connected to port 3. Now, whatever the packets is coming from 0 to 3, the packet should go out from that particular switch to the network area, means other networks. So through the port 1, that you have to keep in your mind. Now observe carefully here, whatever is there. Now the 0, whatever is there, and 3, whatever is there of a switch 2 are connected to other networks. Either it can be output ports, either it can be input ports, which is connected to other networks. Means the data can be received from other networks, the data can be transferred to other networks through this particular ports, that is 0 and 3. And 1 and 2 ports are again the internal means network that is connected to host E and F. Now come to next the switch 3. In a switch 3, observe carefully, the 0 port is the one which is connected to the external network, where it can be collector or means collect the information or send the information to other networks. So internal systems connected to 1, 2, 3. Now, to decide how to forward a packet, a switch consults a forwarding table, sometimes called as routing table. Underline this particular thing. Now here, the confusion between router and a switch will be solved here. So what is a switch hub, which will comes in our real-time example, it will comes under data link layer. Now what is a switch? Manageable switch is nothing but a router. So a manageable switch in a market, we'll call it as a router. Keep in your mind always. If any doubts is there based on this, you can switch on your audio and you can ask me the questions. So if you are preparing one particular network where switch hub is needed and where the router manageable switch, that is router, is needed, you can decide. Now, to decide how to forward a packet, a switch consults a forwarding table, that is a routing table. Now, observe how a routing table, this already we had discussed in distance vector algorithm. Now observe what I told in a previous slide, something, the similarities will be there here. Now destination A is there, you can observe A is there. So A port number 3 which has been taken, and B host B, where is A? Yeah, B is connected to 0, which is just switching table for switch 2. Where is switch 2? Switch 2 is here. Now observe the switch 2 here, how it has been connected to A. It will be always, A will be connected through the external port only, correct? No, so that is 3 here. Now B is connected to 0th port, correct? Why? Because B is there in other network. Now C is there, C is connected with again 3. Why? Because it's a other network. Now you can see that D is also is connected with other network, so that's why it is 3. Now you can see E is connected to port 2, and F is connected to port 1, and G, whatever G is there, that is connected to port 0, and another is port 0 only. Once it goes to this particular router, then this router will take a decision that to which port it should be done. Here, what is the work of this particular switching table? That if it wants to send a packet to A, it will send a packet to switch 1. So switch 1 is connected to port 3 here. So that you should keep in your mind. So whatever switch 1 systems are there, all the switch 1 systems, if it wants to send a packets, then switch 1 systems will be referred through the port 3. And next forwarding node will be switch 1. And later on, switch 1 is the one which will take decision to send to the internal systems. So in this way, a forwarding table will be prepared. Now, characteristics of connectionless or a datagram network. A host can send a packet anywhere at any time, since any packet that turns up at the switch can be immediately forwarded using the forwarding table. So as I told you that anytime any host can send a packet turns up and switch can be immediately forwarded, flooding in nature. When a host sends a packet, it does not know if the network capable of delivering it or if the destination host is even up and running. It never cares for that. Just it floods. I want to send a packet to so and so destination. I will flood. You know flooding, how flooding will be done. So I will move the packet from my side to my neighbors. My neighbors will move from their side. From there, it will move. It will keep on going there, and one person will be there at one as my destination. When he receives that packet, he will decide, yeah, it's my, it belongs to me, like that. So there's a one which is not a definite, not a definite. Way of communication. Either it can reach to my, whether is my destination is there or not at position, is up or not, never bothered about that. Each packet is forwarded independently of previous packets that might have been sent to the same destination. Now, keep in your mind, there's no rule like that. The transferring of a packet should be done in one particular path. No. Whoever this neighbor is free at that time, I will give to this neighbor. I'll give a package. Then they will take, they will receive. Like that, multiple things means ways the destination can receive that. Thus, two successive packets from host A to host B may follow completely different paths. So that's why they can make a different paths. Whichever is free, they will take that particular path. They will keep on moving. A switch or a link failure might not have any serious effect on communication if it is possible to find an alternate route around the failure and update the forwarding table accordingly. Here, the switch or a link failure will never do any problems. Why? Because I am sending in all the ways. I'm flooding my packet in all the ways where my neighbors are there. So then it will move clearly in all the ways. Now, if one link or a switch is filed there, there is no need that in another way I can do the communication. So this will not make so much effectiveness. And the updating of the forwarding table will be done accordingly every quantum time, as I told you. Now, virtual circuit switching, that is connection oriented switching. How a connection oriented switching will work uses the concept of virtual circuit. This is a virtual circuit. What I told before communication, a circuit will be established or a path will be established. Yeah, this is a source node and me the next node. The next node, so shortest path it will decide. So yeah, I will send to next my A node, and I will send to F node, and I will send to D node. Finally, it will goes to E node. Assume this is a perfect path. Once the path has been decided, then the communication will be done exactly in that particular way. So that is called as a connection oriented. Now, uses the concept of virtual circuit here. First, it will establish the path. First, set up a virtual connection from the source host to the destination host and then send the data. Now, host A wants to send a packets to host B. Now, host A is here and host B is here. Now, how this particular host A wants to send a packet to host B, observe first figure. Host A is connected to switch 1 through port 2, right? And switch 2 is connected to switch 1 through 1 and 3. Next, coming to host B is connected with switch 3, and switch 3 is connected with the 0th port and 2nd port of the switch 2. Just you must know this particular thing. Now, two-stage process is there. One is connection setup and another one is a data transfer. How a connection setup will be done? Means first a connection should be established. How a connection setup should be done. Establish connection state in each of the switches between the source and the destination host. That is, first it will know that, means it will ask the corresponding switch. See, my destination is host B. Host B is connected to it. Then that switch will ask the next switch whether that is connected to you. that means you go when we go back to the table here. See, host A will ask switch 1. Say I want to send a packet to switch means host B. Now what this host switch 1 will do, and switch 1 will check first in its particular LAN whether host B is there. No, if it is not there, then it will ask other switches. The other switch connected here is switch 2. Then it will ask switch 2 whether host B is connected to you. Literally to say this, for this switch host B is not connected, and it will check in its particular network whether the host B is there. No, so it will ask the another switch which has been connected here, and then it will ask with switch 3 also. So then the other switch whatever is there, it will tell no, it's not connected to it. Then the switch 2 whatever is connected here to switch 3, again switch 3 will check within its particular network. Yes, host B is connected here. Then automatically the information, whatever table information is there here, will be sent to switch 2, and from switch 2 it will be sent to switch 1, and automatically switch 1 will comes to know that so how much far the host B is there based on the forwarding tables. So like this, already we have discussed that I, on a board also I have solved this problem using a distance vector. Now in this way, the established connection state in each of the switches between the source and the destination nodes. The connection state for a single connection consists of an entry in the VC table. That is a virtual connection table in each switch through which the connection passes. That is, whatever the virtual connectivity table will be there, in that table, which is a next switch entry will be taken into the consideration. Now, characteristics of VC. With the characteristics of a VC, it's somewhat, so we should discuss in depth on this particular concept. We will discuss this in a next class. So I will tell you how a VC table can be constructed in practically with an example, and how that table will help in passing a packet in a particular definite path. So this in an exam view or in a particular knowing the layer view, the VC plays a very much important role, and this we'll discuss in our next coming class on Tuesday. Monday we don't have a class. On Tuesday we are going to discuss on that particular thing. Any doubts now? You can ask me. Switch on your audios. Any doubts? Switch on your audios. Hello? Hello? Any doubts? Sunil? Another doubt is no? Huh?
ಇಲ್ಲ ಸರ್
ಸುನೀಲ್ ಹೇಗಿದೆಯಾ?
ಸರ್ ಚೆನ್ನಾಗಿದ್ದೀನಿ ಸರ್. ನೀವು?
ಚೆನ್ನಾಗಿದ್ದೀನಿ ಕಣ. So everyone understood? Any problem? Akash?
No sir, no problem sir.
Any doubts is there, you can ask me. If you are feeling to ask here, means another problem is there, you can WhatsApp me individually. Any doubts is there, and I will know that particular doubts. And this video will be put in a department channel. If you are getting doubts, again you can watch this particular video. Still doubts are there, you call me. Next class onwards, we will go in how we say, well, means how routing will be done and all. I will explain you. Okay.
Yes, sir.
Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Sir.